Maintaining indexes. One of the big responsibilities as a DBA is ensuring that our databases optimally perform. And we do that through indexes. Indexes are one of the greatest ways to improve performance in a database. But the thing with indexes is they degrade over time. And so we need to have optimal maintenance strategies in place to ensure that our indexes are always in tip-top shape. In the world of 70-464, we have three objectives that deal with indexing. We have this one, maintaining indexes, which really comes after the fact. We're kind of going backwards here. But after your indexes have been in the wild, they start to degrade. What do you do to get them back to the best possible shape? We have a nugget on creating and altering indexes. So that's really going to be your developing indexes nugget, where you're going to get really familiar with the code and all the ways that we can create them. And then we have one for design and optimization, how to find what to index, so on and so forth. So let's get back to this nugget here, which is solely on maintaining indexes. And we're going to start here by just getting an overview of what index maintenance consists of. It helps to understand what fragmentation is, internal and external fragmentation. And then we'll also look at rebuilding indexes versus reorganizing indexes. We'll get you some analogies and some visuals as well. Then we will jump into some guidelines, talk about an index maintenance checklist. Everybody needs a checklist when it comes to maintenance. And so I got a checklist for you, some things to think about and some general guidelines to follow. We'll also go over some tips for preventing fragmentation. I know that's more for a design discussion, but I figured since we're going to be talking so much about fragmentation in this nugget, that it would be a good place just to throw some tips your way. And then we'll also talk about maintenance plans versus custom scripts. And if you read into that, it's more like need to know for certification versus need to know for real world. So I've got some really good real world stuff in here for you, and it's all going to revolve around a gentleman by the name of Ola Hallengren, who made this amazing stored procedure that almost everybody out there is using. It's won awards, and it's just because it's so simple to use. And it works for all levels of fragmentations, all levels of databases, comes packed with options. So it is the greatest real world example of how to do index maintenance. So once we get familiar with all that stuff, we'll jump into the virtual Nugget Lab. We'll start with a fragmentation demo, where we will simulate fragmentation. We'll create a table, load it up with data, put some indexes on it, fragment the heck out of those indexes, and then figure out what to do and where to go from there. And that's really going to be the next area here, which is how to identify them. Where do we look? Where do we find all this fragmentation information? We've got everything from Management Studio GUIs to DMVs to reports. And then once we identify them, how do we go about fixing them? And that's going to come down to rebuilding versus reorganizing, and again, coming up with a maintenance strategy. So once we get familiar with that here, the last little bonus area I just want to throw in is how to do real world index maintenance using Ola's awesome stored procedure. So we'll get that stored procedure installed, and I'll show you how we can run it and do some pretty neat real world index maintenance. Let's start here with an index maintenance overview. And the big thing that everyone talks about when it comes to index maintenance and index performance is fragmentation. Fragmentation is what plagues our indexes and our disks in the operating system world, because as data comes in, data goes out, or data gets modified, things have to get moved around. The whole idea here is that we want to keep it contiguous. We want to keep it in sequence. If things are in sequence, it's a lot less work for our I/O subsystem to do, because they can just read it sequentially, right? But if there's data all over the place out of order, then it has to jump all over the place. So that's kind of the formal definition, is fragmentation is when data is stored non-contiguously on disk. Let's look at a real world analogy. When it comes to indexes and index design, I like to use phone books and regular books for retrieving data. I think with fragmentation, it's a better analogy is a bookshelf or a bookcase. So there's two forms of fragmentation. There's internal fragmentation and there's external fragmentation. Internal fragmentation happens when new data comes in and there's no room for it. So in our bookcase example here, let's say the librarian got a cool new book in and they want to put it inside of this bookshelf. They walk over to this bookshelf, sees that it goes right here, tries to stuff it in but can't do it, and now they need another bookcase, right? They need another bookcase to maybe move half the books over there and leave half the books over here. And the problem with that is now that we have two data pages that are both half full instead of one full data page. And that's going to hurt caching, because SQL Server caches at the page level. So now just caching one full page, it has to cache two full pages because that empty space is allocated. Now, external fragmentation has to deal with the bookcases themselves. In fact, building on our previous analogy, let's say that the librarian took all these bottom books here and moved them to that new case so it could make room for that new book. But the problem is, the librarian couldn't just put that new case right next door because there's already a bookcase there full of books on both sides. In fact, all the new bookcases, yeah, they're at the end of the library, 10 aisles down. So all those books are over here, and now look, we have our bookshelves out of order. So anybody that comes and is looking at these books and says, oh, no, that book is going to be down in these letters somewhere, which are over there. Now they have to walk all the way around the library to get to that bookshelf, which is the result of a lot of wasted I/O. So internal fragmentation is the data itself within the pages, usually caused by page splitting. External fragmentation is new shelves placed out of order. So it all comes down to just sequentialness, if that's even a word. Contiguous access. We want our data and our pages and our extents all to be contiguous. That is the ultimate goal. And when you build an index, that's how they are. And when you rebuild an index, that's going to be the end result, is contiguous data across contiguous pages, which results in better caching. We're only loading what we need to into the buffer pool and less work for our I/O subsystems to do. Let's see how this looks at the SQL Server level. So over here we have everything's in order. Page 1, page 2 are sequential. Rows are all sequential across those pages. So this is ideal, right? This is what it looks like when you first create an index, when you rebuild or reorganize an index. This is the ultimate goal. That's as best as we can get, 0% fragmentation. Over here we have pages out of order, and we have our rows that are in order, but actually they're not in order because we have rows 5 and 6 down here. But let's say that we were to insert a new record into this page. SQL Server would look, or into this table here. Let's say this was one table. If it were to insert a new record into here, it would look for an empty spot and put it in. So where are we at here? 10. Here would be 11. Say it did it again. 12, 13, 14, 15, and 16. So everything's out of order. We're extremely fragmented here. And now if we were to insert another one, it would do a page split, create a new page, move half the rows there and half the rows there, and now you can see how things get out of order rather fast. And there's a couple of ways that this could happen too. This page splitting is not just on inserts, but say somebody updated a record that is now too big to fit on this page. Same thing. It's going to split, create a new page, move half the rows over and over. So things can get out of order pretty quick. And even worse here, let's say that these are on different extents. So this is extent 1. Extent is just a contiguous block of 8 pages. But let's say that we have now extent 1 and extent 2. If SQL Server needs to go look for data across extents, now it's doing extent switching, which is even more I/O and more of a performance hit. So that's fragmentation in a nutshell, internal and external. And that's what we want to avoid. So if you're in SQL Server Management Studio or you're running a DMV or looking at a report and you see that your index is 80 or 90% fragmented, this is what it looks like under the hood. And this is what we want to get it to. So performance problems, the big ones come from poor design, the lack of indexing, or extremely fragmented indexes. So how do we fix it? By rebuilding or reorganizing our index. Both of these have the same end in mind, and that is getting us to sequential everything. Now, there are pros and cons to both of these, and which one you choose is going to be dependent upon your situation, your environment, your database, so on and so forth. Most people tend to lean towards rebuilding. Rebuilding is cleaner, it's easier, and it's usually a lot quicker, especially on large databases. It's much quicker. You do lose a little bit of concurrency when doing an online rebuild because it creates a schema M lock. And on top of that, if you were to say, do an online rebuild during the day and say, oops, I did it during the day, it's sucking down all these resources, and you hit cancel in the middle of it, it's actually going to roll back everything that it did. Reorganizing is better for concurrency, and on top of that, if you were to cancel something that's been running for a while in the middle of the day, it'll just stop right there. So you won't lose all the work that it did. But ultimately, both of these lead to this right here, which is what we want. We want sequential everything. So the general idea here is rebuild if you can, reorganize when fragmentation is low, or you can't do a rebuild because you're a 24/7 type shop. All right, let's go look at some guidelines and get some tips here for index maintenance. Let's start with a checklist and some general maintenance guidelines here. The first one, obviously, identify and remove fragmentation. That's going to be the big one. The second one, identify and remove unused indexes. Unused indexes don't do anybody or anything any good. They waste space, they waste resources. Let's get them out of there. So I'll show you an easy way to identify and remove them. Identify and create missing indexes. I know, that's an obvious one, but it must be said. Rebuild, reorganize indexes weekly. Again, these are just general tips. It's all going to be depend on your situation, but a good general strategy is to rebuild or reorganize weekly and then update statistics daily. Statistics are very important so the query optimizer can make and do the job that it's supposed to do best. So if the statistics are out of date, it's going to take the not the best path to find the data, right? That's what the query optimizer is all about, finding the best path to our data. It does that based on the statistics. So if our statistics are up to date, the query optimizer can do the job to the best of its ability. Another one, and these two are right from Microsoft. Microsoft suggests this. Some people in the community argue that they're not good for every situation, and they're not. They're not, but they're good general guidelines to follow because they're going to cover 80 to 90% of the databases out there. And that is rebuild when you have greater than 30% fragmentation, reorganize when you have in between 5 and 30% fragmentation. Those are great general guidelines to follow. Also, create a job to automate all this stuff. And not only just create a job, don't create a job and forget about it, but create a job and then monitor and tweak it. Our databases change, our users change, applications change. So the state of our data can fluctuate, and the state of our database fluctuates, obviously. So that's why it's good to monitor these puppies to make sure that they're not taking longer than they should or something else isn't going on. So create a job, automate it. What kind of job are we going to create? Well, and I hesitate to even say this, but use maintenance plans on small databases and then use a custom script for everywhere else. I really just want to say use a custom script all the time in the real world because they're flexible. They don't leave a lot of baggage. These maintenance plans that you use in SQL Server, it's an all or nothing proposition. You're either going to rebuild every index in a database or all indexes in all databases. And you can't really specify if fragmentation is less than 5, don't do a rebuild. It's going to do a rebuild no matter what. If there's 1% fragmentation or 99% fragmentation, it's going to do its job. And there's a lot of baggage that comes with it because every time it does that, it's clogging up our logs. And that's where it gets really bad. I've heard of maintenance plans that generate 300 megabytes of log information in a 1 terabyte database. That is terrible because that's going to clog up and bloat your backups amongst other things. So that's why I hesitate to even say use maintenance plans at all. But hey, we're in the world of 70-464 and certifications. We need to know how to use this stuff and that they exist. So I'll just say for now, wink, wink, only use maintenance plans on small databases. Let's go over a couple of tips for preventing fragmentation. So the big one here is that we ultimately want to reduce page splitting and low page data density, which basically means we do not want a lot of empty pages with a little bit of data on them. We would like fewer pages full of data. Now, that is, again, a kind of a best practice general guideline, and that's going to be good for most cases. But if you have a table that has an insane number of inserts, like thousands of inserts every minute or so, then you're probably going to want some space on your pages to reduce page splitting because we want those inserts that are all coming in and updates that are coming in. We want to reduce page splitting by having it just fill up pages that have extra space on them. But in general here, we want to reduce page splitting and we want to avoid low page data density. How do we do that? Well, one way to do it here is to choose index keys that are sequential. And we're going to prove this when we get into the virtual Nugget Lab because we're going to create a sequential table and a non-sequential table, put an index on IDs of both flavors, and you'll be able to see how crazy the fragmentation gets with even just working with a little bit of data for non-sequential fields. So index fields or columns that are sequential if you can. People got into a lot of trouble with these babies. GUIDs or GUIDs. I like to call them GUIDs. I know a lot of people like to call them GUIDs, but it sounds too much like squid to me. GUID sounds awesome. So a GUID here is what a lot of people use, right, for unique IDs, but some people even use them as primary keys, right, clustered indexes. And that can get you into trouble because they're randomly generated. At least they were with new ID. Thankfully, we've got this sweet new keyword, new sequential GUID, which creates them in order. Fragmentation concerns gone. So really, really cool. If you do use GUIDs there for your primary keys, your clustered indexes, or any form of indexing, definitely use new sequential GUID to generate them. Also choose static index keys when possible. Index keys that don't change are exactly what you want inside of your index because that just simply means they're not going to get changed, so they're not going to get reorganized around. It's going to result in less page splitting and better performance overall. And then finally here, use fill factors carefully to avoid low page density. And we'll get into proper fill factor design, but understanding fill factors is critical before you use them. General guideline there again is you use a lower fill factor when you have a lot of activity on a table because you want a little bit of space there to reduce page splitting. And on tables that do not have a lot of activity, you want a higher fill factor so your pages stay full, which again result in less pages. But the overall thing here is we want to avoid low page density because again that results in more disk space, more I/O, and more memory inside of the buffer pool. So more on fragmentation and how to properly design our indexes in a future nugget. All right, I think it's about time we head into the virtual nugget lab and do some work. We'll start with fragmentation. We'll simulate it. I'll show you how to identify it, the different ways that we can find it, and then fix it. And then we'll look at real-world index optimization. All right, here we are. Welcome to the virtual nugget lab. Down here we have SQL Server Management Studio wide open, ready to go. I've got a new project in here called Index Maintenance, where we have a bunch of queries to work with. Now, so what we're going to do first here is just simulate fragmentation, as I mentioned. So let me open up our frag.sql script here. Let's switch our database to the Nugget Demo DB database. Excellent. And the first thing I want to show you here is sequential versus non-sequential indexes. And we're going to do this on first an auto number field is going to be our sequential, so it'll just be 1, 2, 3, 4, so on and so forth. So that's a nice sequential field. And then our second table is the exact same. It's just called non-sequential, and we're going to use a unique identifier field with the new ID that randomly generates GUIDs. All right, and then we're going to create a clustered index on both of those. So that's going to be our first step. Let's do that. Let's highlight both of these. Let's create them. Now let me go into databases here. Nugget Demo DB will just refresh our tables, and we should have them both in here. Excellent. So let's just verify that our indexes were created. They were. If we go to the properties, head into fragmentation, we're 0 and 0. All right, so excellent. Next step here, we're going to insert 1,000 records into each of these tables. And I'm doing it without a loop. This is actually kind of funny. Here's a cool little trick. If you want to run a statement more than once, put a value after go. This is going to create 1,000 insert statements. Kind of neat, huh? Cool, fun little trick there. And so frags, both of these are going to do the same thing. They're going to insert just some random data. Well, I should say the same data randomly in length into this. So the first one here, we're going to replicate the value name to go into the name. And this is just a fancy little trick here to generate a random number, in this case between 1 and 10. This one will create one between 1 and 50. So it's going to replicate this value between 1 and 10 times for name, this value between 1 and 50 times for some data. All right? We'll do the same thing then for our non-sequential table. So we're doing the exact same thing. The only difference here is that we have our ID non-sequential on one and sequential on the other. All right, so let's execute that. Take just a second. Beautiful. And now let's first look at our sequential one here. Let me expand sequential indexes. Let's go to properties, fragmentation, 5%. Not bad, right? Now here's the cool thing. Watch this. Let's do our sequential one. Let's insert another 1,000 records and see what happens. Think we'll get worse or better fragmentation? Let's find out. Properties, fragmentation. It was better. See that? Because it's sequential. It just kept filling up the pages as it goes. And when it needs a new page, it creates a new page and it just keeps filling up. It's not reorganizing anything. It's not taking things away. So we actually got better results there, which is kind of neat. Now, let's go look at our non-sequential tests. Let's right-click, go to Properties, go to Fragmentation. 98%. And I can almost guarantee you if you ran it again, we'd be at 99.99% fragmentation. That's pretty bad. So that just goes to show you something as little as putting an index on a field that is non-sequential can do to the index. And now I know every situation is different. We like to index our fields that our where clauses are hitting. And sometimes those are going to be character fields. Sometimes those will be date fields. And so, sequential will be out of our control. But just note, do this if possible, because you can see the difference there. And if it's not possible, we just have to make sure that we plan accordingly and have a maintenance plan in place, right? Now, the next thing I want to take you through is updates. Updates, and we can see what happens here when we update both a non-key column and a key column. So the first thing we're going to do is just clear out our frag test sequential table. So we'll start from scratch here. And let's just do that. Let's just make sure that it was cleared out. We'll look at our fragmentation 0, 0. Okay, good deal. Now, the next thing we're going to do is just put more data into that table. But this time we're going to add something a little bit different. We're going to, rather than just generate 1,000 records, we're going to generate based on sys.columns. That way we can pull a relevant value into the name field, and then we'll update that key value by, say, reversing it or something to that effect. It's just something to change. So you'll see how updating your keys affects fragmentation. All right, so let's add some data in here. And right now, so we've got 762 rows. If we were to look at this, it really shouldn't be too bad. We should be just like where we were. Okay, 16%. So we're kind of fragmented there. But our pages are nice and full. Nice and full. 97% full. So that's good. That's what we want to see right there, is nice full pages and low fragmentation. All right, as opposed to our non-sequential test, which I bet if we go look at that, has the opposite. Yeah, look at that. Our pages are 66% full, so we've got low data density mixed with high fragmentation. So this is what we want to avoid, and this is what we want to aim for. All right, so now with that in place, the first thing we're going to do is update that field some data. We're just going to run the same thing, and we're going to say go ahead and update every other field by doing a where ID modulo 2 equals 0. That just means do every other field. So here we're going to update a non-key column. We're going to see how that affects fragmentation. So let's go into our sequential, into properties, fragmentation, and look at that. We've raised fragmentation up to 80%, and we lowered our page density. So that just created a lot of page splits. And it created a lot of page splitting because when we updated every other row with random data, some data got bigger, which means it may not have all fit on a page, so that caused page splits. And then on top of that, it just had to add a lot of data in there and shuffle it around. So yeah, that was a bad thing right there. What about a non-clustered index? Let's add a non-clustered index here on our name field. And just to prove this here, let's right-click, go to refresh. Let me hide this one. And let's look at this index. It should, since we just created it, be about as good as it's going to be. Look at that. No fragmentation, and our pages are 95% full for this index. So that's good. That's what we want. Now let's do something very similar. This time we're going to update every fifth row by just reversing what's currently in there. So we're just going to run an update and reverse every fifth row inside of here. If we hit an execute, that's going to update 152 rows out of the 762. And what did that do to this index? A lot. That did a lot. So you can see updating keys. Keys that get updated a lot are also going to cause a lot of fragmentation. Again, low data density, high fragmentation. That's bad. We want to aim for high data density and low fragmentation. So proper design is going to take us most of the way when it comes to this, but the rest of it's all going to be defensive efforts on our part to come up with an optimal maintenance plan. So what do we do when we think performance is starting to degrade, people are starting to complain? Well, we're going to need to find out. And we've looked here. One way to find out is to pretty simply just use Management Studio here, right-click on an index, and go look at the fragmentation and the page fullness. But I got to show you more than just that, right? So let's go into our identify script here. And this, I'm going to show you two DMVs. One is index physical stats. This is what we're going to do to identify fragmentation. It's pretty much the same information we're going to get out of the GUI just through a DMV. And then I'm also going to show you how to identify unused indexes using another DMV. And I'm just going to mention a couple of other ways that you can find this information as we just saw here through SSMS, but there's also reports here. If you right-click on a database, head into reports, go into standard reports, down here, index usage and index physical statistics. Those are some nice reports that you can drill into and get some good information around fragmentation and even usage statistics on your indexes. Pretty much both what I'm going to show you here how to do in T-SQL. These both power those reports. Let me start here by switching our database to Nugget Demo DB. You can see the physical stats. The first parameter here is the database ID. We're passing in the current database ID here, so that's why we needed to switch. But this is actually pretty simple. So we take this DMV, we join it to sys.indexes so we can pull out the index name. And then I'm also adding a little where clause here to only show us indexes that have greater than 30% fragmentation. So this will be good for identifying the indexes that we would want to rebuild. All right, so let's hit execute, and look at that. We've got plenty of indexes on here that we're going to need to rebuild. All the ones that we created, and then even some ones that we have on our demo tables, trainer, nugget, and nugget. We've got some pretty heavy fragmentation here too. So just a great simple DMV to use to identify fragmentation. The other one down here will help us identify unused indexes. And it's going to use the usage stats DMV here. We're joining this to sys indexes, just a few filters on here to only grab user tables and look in the current database. But essentially what this is going to do for us is find seeks, scans, lookups, and updates. The big ones here are seeks and scans. If seeks are obviously much better than scans. Seeks just basically means it used the index. It made an effective use of the index to find what it needed. Scans means it had to look through the entire index to find what it needed. But the bottom line here is that if you find indexes, and as long as you didn't just create them like we did, and they look like this, they have a low number of seeks, especially a low number of seeks versus scans, then you know that that index is not being used, and you can probably get rid of it, or at least it's a good candidate to take a second look at to see if it's actually going to do anything for you rather than just take up space and resources. Now, the last thing I want to show you here has nothing to do with the exam or the certification, but it's a great real-world solution for index maintenance. So you're out there, you're in the wild, you're looking for a good solution, this is the one. So let me take you over to the website here, ola.hallengren.com. And he's got scripts that cover backup, integrity checks. The one we're interested here is going to be index and statistics maintenance, but it's won many community choice awards simply because it's flexible, it's easy to use, and it's free. Big one there, right? It's free. So let's go over to the index and statistics maintenance side here, and this is just a really easy page to consume too, because it lists all the parameters and their values. So we have full control over what databases we want to run our index maintenance on. And then we have full control over all the different levels. So we can specify what we want to do if fragmentation is low, medium, or high. And then we have control over those values. So fragmentation level 1 is the lower limit for medium, meaning anything before that will be considered low fragmentation. Anything in between level 1 and 2 then is medium, and anything above level 2 is high. And we have full control over these values as well, but the default, based on Microsoft's recommendations, as we've been looking at, default is 5 for level 1 and 30 for level 2. Now, the real beauty of this script is that, see all these options in here? Every fragmentation level, you can pass in a single option or a bunch of these options, and if something isn't supported on a specific version or edition, then it'll fall back. So we can pass in index rebuild online, index rebuild offline. It'll do online if it's supported. If it's not, it'll fall back to an index rebuild offline. And then it also incorporates that with reorganize, and then both reorganize and rebuild. So really, really cool. Now, if you want to download this, you can download the entire thing. Maintenance Solution.SQL will download everything, backup, integrity checks, and index and statistics maintenance. If you want to download just specific things, though, you can hit the download as a separate script here. And the ones that you're going to be concerned with if you're going to do index optimization is right here, indexoptimize.sql. And also, it does have a few dependencies here, command-execute.sql and command-log.sql, if you want to log this information to the table. So I've downloaded these three into our project here, index maintenance. I called it Ola_index optimize. So I downloaded command-log, command-execute, and the stored procedure that we're really going to be concerned with here is going to be the actual index maintenance one, which is right about here. We're almost there. Here it is right here, index optimize. So you can just look at this stored procedure and you can see all the parameters, you can see the default values built into them. But let's go ahead and run this, and we'll just install this in the master database here. So I will highlight everything, hit execute. That'll create the log, create the execute log stored procedure, and then create the big one here, which is going to be the index optimize stored procedure. And now we can execute it. And here's an example of how to execute it. We're going to execute this here against just our Nugget demo DB. Again, we're not going to do low fragmentation, so anything under 5% is going to be left alone. Medium, we're going to do an index reorganize, index rebuild online, and index rebuild offline. It'll do the highest one that is supported in our version and edition. And that will do everything in between 5 and 30%. Then for high, it's going to do a rebuild. So essentially here we're going to get a reorganize for medium fragmentation. We're going to get a rebuild for high fragmentation. And just to show you here, you can specify these fragmentation levels. Those are the defaults though. And then we're also going to update statistics. So let's run the stored procedure. We'll just highlight our execute code here, hit execute, gives us some nice information here about what it did and what time it did it and such. But now we could go and run a DMV, which won't bring back anything now. But if we want to see if this worked, let's just right click on our index, go to properties, head into fragmentation, and look at that. A lot different. We were 80% fragmented before, and our pages were about 55% full. Well, now we have nice page fullness, so high data density along with low fragmentation. We could look at our clustered index, and we should get the same results. Excellent. So the last step then would be to automate the execution of the stored procedure with all of your desired parameters, and that's easy to do. You can set up a SQL agent job with a command exec step in it. And in fact, over on Ola's site here, the index and statistics maintenance page, if you go all the way to the bottom, he even gives you the line of code to use, the command exec line to use here. The only thing you need to do is paste in the execution of your stored procedures with your desired parameters inside of the quotes, and you're good to go. So that's about as good as it gets for automated index maintenance in the real world. In the CBT Nugget, we learned how to maintain indexes. We started off with an overview. We got familiar with what fragmentation is all about, how it hurts performance, and how to fix it through rebuilding and reorganizing our indexes. We saw some index maintenance guidelines. We got a checklist, many things that we need to think about when coming up with an index maintenance strategy. We also took a look at how to prevent fragmentation, and then talked about the differences between the built-in maintenance plans and your own custom script. Then we jumped into the virtual Nugget Lab where we took a big look at fragmentation. We simulated fragmentation. We saw how to detect and identify it using DMV, SQL Server Management Studio, talked about reports, and a couple other methods for doing so. Then we also saw how to maintain it, and just got you familiar there with the rebuild and reorganize statements. And at the end here, we looked at some real-world index maintenance using Ola Hellengren's index maintenance script. I hope this has been informative for you, and I'd like to thank you for viewing.